Hey everybody, welcome back to my YouTube channel. So today we have a really exciting video in store. We are going to be talking about, drum roll please, dun, 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 similar triangles. So similar triangles, I've been getting so many requests on TikTok to do some videos on geometry. It seems to be a common area that everyone is struggling with. So we're going to talk today about similar triangles, how to approach questions with them, common tactics for recognizing that triangles are similar, and so on. So if you need some help with similar triangles, keep watching. And without further ado, let's jump into today's video. All right, so let's just start off with some basic definitions for similar triangles. Like, what exactly does it mean for two triangles to be considered similar? So there are really two things that we want to focus on. So the first thing is that similar triangles have corresponding, aka matching sides that are proportional. So what do we mean by proportional? I just randomly drew in the angles and the sides here. This is just whatever I decided to do. But if you notice for triangle ABC, each of the sides is 2 times what it is for triangle DEF. Like if you notice, in order to get from 8 to 16, you multiply by 2. To get from 7 to 14, again, you multiply by 2. And to get from 5 to 10, again, we just got to multiply by 2. So that's what it means to be proportional. The sides of one triangle are a scaled version of the sides of the other triangle for the two similar triangles. And the second criteria is that the corresponding, aka matching angles, are going to be equal in measure. So if you notice, for each of the angles that occupies the same position in the triangle set, this is 90, this is 90, this is 40, this is 40, this is 50, this is 50. So they match up in terms of their measure when they occupy the same position in the two similar triangles. All right. And if we notice, it says right here, corresponding sides are opposite corresponding angles. So if you can see the 10 and the 5, these are the corresponding sides, and they are opposite the 50, both of them, opposite the corresponding angles. So let's look at two questions so we can just see how similar triangles work. So it's really important to understand that when they tell you that one triangle is similar to another, it's really important what the ordering is. So because they say ABC is similar to XYZ, that means that A and X occupy the same position, B and Y occupy the same position, and then C and Z occupy the same position over here. Alrighty, so they ask us to find the length of AC. So in order to find the length of AC, we first have to figure out what the scale is, what the proportionality is right here. So we could see that this side corresponds with this side. So in order to get from here to here, we have to multiply by 5. So let's go ahead and do the same thing over here. Multiplying 6 by 5, we get that this side then is going to be 30. So AC is equal to 30 as our answer. And then they ask us, what is the measure of angle Z? What is the measure of angle Y? So angle Z occupies the same position as does angle C. So this angle right here, angle Z, has also got to be 40 degrees. Angle Y occupies the same position as angle B. So angle Y has got to be equal to 80 degrees. Another note is that when we have two pairs of congruent angles, that's enough to create similar triangles in terms of a criteria. So if we have two pairs of congruent angles, the triangles are automatically similar. So if we notice, for example, in example A, we could see that this angle and this angle are the same, and this angle and this angle are the same, so that makes these are two similar triangles. So what we mean by the two similar triangles is that we have this smaller one right here, and then we have this bigger one on the outside right here. These two are similar. Same thing goes for B and C. But I want to point something out that's unique to A and B. So if you notice right here, we have one smaller triangle in a bigger triangle. So I would say 99.9% of the time, seeing a smaller triangle within a bigger triangle, that should be screaming, the alarm should be going off that we're dealing with similar triangles. That's very, very commonly the case. So when you see a baby triangle and a bigger triangle, you should be thinking similar triangles. Let me deal with the proportionality and all of the stuff that we've been talking about. Alrighty, so we're going to begin with question 17. So I just went ahead and labeled all of the sides that they told us. They told us that AB was 1800, EB was 1400, BD was 700, and CD was 800. So I just went ahead and labeled that. And then they told us that the two angles that we see right here, angle AEB and angle CDB, these were exactly congruent in measure. So then they ask us for what is the value of X. All right, so we already have these two angles that they told us are the same. And then angle ABE right here and angle CBD right here are going to be equal in measure because these are opposite angles. I can definitely do a separate video on angle properties for sure. But these two angles are equivalent. So we said that two pairs of congruent angles is enough to call for similar triangles. So we know then that these are indeed similar triangles. So what that means then is that the sides are going to exhibit proportionality. I can see that the sides that go together, the 1400 and the 700, well, the difference between the two is that the bigger triangle is 2 times the length of the sides of the smaller triangle. So I know then that the 800 is going to match up with X. So if this is 800, we just have to multiply that by 2 to get what X is going to be. So 800 times 2 is going to give us 1600 feet for the value of X. Next up, we're going to check out this question. So they tell us right here that AE is parallel to CD. Whenever we have these two lines like that, that signifies that we're talking about parallel lines and that they both intersect at point B. All right, so because these are parallel lines, what that means then is that angle A right here is the same as angle D. Angle C is the same as angle E. So that's already enough to qualify these as similar triangles. So they then ask us, what is the length of CE? This full thing right here, I'm just going to call that X so we can identify that. So we want to notice what the proportionality is. The bigger triangle sides are double those of the smaller triangle. So that means then that we have to multiply the smaller triangle sides by 2 to get the sides of the bigger triangle. So let's go ahead and realize that BE is equal to 8. So in order to get the smaller triangle, we are just going to divide that by 2. So that means that CB is going to be equal to 4. However, they want the length of CE, which we're calling X right here. So CE, which we said is equal to X, is just going to be 4 plus 8. So 4 plus 8 is equal to 12. I actually really like number 16 for demonstrating similar triangles. So if you notice, we have a right angle over here. So these two angles are the same. And then we have that this angle is 32 and this one is 58. Well, the angles, the three angles of a triangle have got to sum to 180 degrees in total. So what that means then is that if this one right here is 90 and this one is 58, angle DEF has got to be 32. And over here, angle ABC has got to be 58 degrees. So we could see that these triangles are actually going to be similar triangles then because they have at least two angles that are congruent to each other. So they're asking which of the following is equal to the ratio of BC. So we want BC over AB. So AB. So basically we want then, remember that the corresponding sides are also opposite corresponding angles. So basically on the top we want the side opposite 32 degrees, and then on the bottom, because that's BC, and then on the bottom we have AB, the side opposite the 90 degrees, aka the hypotenuse. So in this triangle we can see that the side opposite 32 is going to be DF on the top. And then the side opposite the 90, aka the hypotenuse, is going to be DE. So as our final answer, that gives us then choice B. All right, so let's finish up with this question right here, number 18, which is a more difficult version, in my opinion, of what we've been doing. So we can see right here that we have a smaller triangle inside of a bigger triangle. So that's probably, again, a sign that these are similar triangles. So they're asking us for the length of CE, which is this side right here, the hypotenuse of the big triangle. Alrighty, so let's go ahead and work with what we know. We can see that the sides of the big triangle are 3 times the length of those of the small triangle. So what that means then is that if BC right here is equal to 8, we just have to multiply 8 by 3 to get the big side here, which is AC. So 8 times 3 gives us 24. So this side right here, AC, is equal to 24. So we have 2 sides right here of this right triangle. So what that means then is, of course, we could do the Pythagorean theorem to find the hypotenuse, but these are really ugly numbers, so we probably don't want to go ahead and do that. So on the SAT, there are 2 Pythagorean triples that you should be able to recognize, and you should be able to recognize scaled versions of them. So there's the 3, 4, 5 triple. The reason why you get the 3, 4, 5 triple is because when you do 3 squared plus 4 squared equals x squared, you get 9 plus 16 equals x squared, 25 equals x squared, so x equals 5. And then there's also the 5, 12, 13. These are very common triples that they use on the SAT. You should have these committed to memory. But what we want to realize is that a 3, 4, 5 right triangle is the same exact thing then, I'm going to put this over here, as a 6, 8, 10 right triangle, or as a 9, 12, 15 right triangle, because these are just scaled versions of this. This is just multiplying everything by 2, and this is just multiplying everything by 3. So what that means then is that if we look at this is also another version of a scaled 3, 4, 5 right triangle. 18 is just 3 multiplied by 6, so it's just scaled by 6. 24 is just 4 multiplied by 6. Gives us 24. So this side right here is just going to be 5 multiplied by 6 to give us 30. So what that means then is that what we're looking for, which is CE then is equal to 30. So that is our final answer. Thanks so much, guys, for watching today's video. If you enjoyed, make sure to thumbs up and subscribe to my channel. Again, guys, just wanted to let you know I do run a TikTok page. Got a little bit of TikTok clout. Test Prep Tips is the handle, so definitely make sure to give me a follow over there. And any links for our upcoming courses and also our SAT Math Workbook, I'm going to drop all of those in the description below. Again, guys, thanks for watching.